They're asking which of the following five physical parameters have same dimensions. Okay, let me check the first one. So what's the first one? Energy density. So just now I have explained what is the meaning of energy density. Here it is. Energy density is nothing but energy per unit, energy per volume. So what is the formula? It is m power 1 L power minus 1 T power minus 2. Okay, next one, refractive index. Refractive index is a dimensionless quantity. Refractive index. So it is a dimensionless quantity. Next one, third one, dielectric constant. Dielectric constant. Dielectric constant is also dimensionless. Dimensionless. And one more thing, what is the thing they have given? Young's modulus. I've already explained. Young's modulus dimensional formula is the same as stress. Young's modulus, which is equal to stress by strain. Longitudinal stress by longitudinal strain, which is equal to m power 1 L power minus 1 T power minus 2. If you observe, dimensional formula for Young's modulus and energy density both are same. So energy density and Young's modulus are matching. So option A is correct. Young's modulus and energy density are having same dimensional formula. You may ask me, what about remaining things? I mean magnetic field. Magnetic field formula is represented as, let me explain you that also. Whenever a charge is moving in a magnetic field with some velocity, then there is a formula for force acting on that charge in the magnetic field is F is equal to QVB. Actually, it's a cross product of V bar and B bar. You are going to get sin theta that is not having any dimensions. Then you have to represent only for dimensions for this. Then B is equal to force by Q into V. Where Q is charge and V is velocity or speed of that charged particle. F is force. So from this we can write down dimensional formula. Dimensional formula is m power 1 L power 1 T power minus 2 divided by charge dimensional formula. I is equal to Q by T. Then Q is equal to I into T. Then dimensional formula for charge is A into T. Let me represent that A into T. What about speed or velocity dimensional formula? It is going to be L power 1 T power minus 1. So finally dimensional formula for magnetic field, it is going to be m power 1 T into T power minus 1, it will get cancelled. L power 1 is there, A power minus 1 T power minus 2. This is the dimensional formula for magnetic field. Now look at question number 21. They are asking dimensions of resistance in an electrical circuit, but they are asking in a different terms. In terms of dimension of mass, length, and of time t, and of current I. So the dimensional formula should be of these terminals. Okay, let's get started. General formula for voltage V is equal to I into R. Let me start with this. Then R is equal to V by I. Okay, so one of the unit I need is I got it. I have to convert this V. Here this V is a potential or voltage that I have to convert. So general formula for voltage or potential in terms of work done is R is equal to work done by charge divided by I. This is the formula for potential. Potential is nothing but amount of work required to displace a charge from one position to another position. Very good. So work done by charge into I. I have to convert this charge again into I. Here itself I have represented. Q can be represented as I into T. So final dimensional formula. Work done dimensional formula is m power 1 L power 2 T power minus 2 divided by charge is I into T power 1 into I is there. So final dimensional formula we are going to get, if you take this T power 1 to numerator, we are going to get m power 1 L power 2 T power minus 3 I power minus 2. This is the dimensional formula for resistance in terms of mass, length, time and current. Hope you understood. Look at question number 22. The question they are asking is the ratio of dimensions of Planck's constant and that of moment of inertia. Planck's constant to moment of inertia dimensional formula they are asking. Okay, general formula for energy is equal to hc by lambda, right? Or you can write down this is as h is equal to E into lambda by c. So what's the formula for frequency? You can write down c by lambda as a frequency, I guess. That means you can write down h is equal to E into f. Otherwise you can write down h is equal to E by t. Here E is energy. Okay, hope you are able to understand. So moment of inertia for a particle point mass is mr square. So let me represent dimensional formula for all these things. You can represent this is as E by t into moment of inertia. E is energy, t is time, I is moment of inertia. So I've already told you moment of inertia of a point mass is mr square. I is equal to mr square. This is applicable for point mass. I am talking about formula. Formula is mr square for a point mass. Let me represent the final dimensional formula, which is equal to m power 1 L power 2 T power minus 2 is the dimensional formula for energy divided by time dimensional formula T power 1. Then moment of inertia dimensional formula mass into distance square. It is m power 1 L power 2. So finally we are going to get m power 1 L power 2 goes to numerator. It will get cancelled out. So it is going to be sorry m power 1 also will get cancelled out. It is going to be m power 0 L power 0. If t power 1 goes to numerator, it is going to be t power minus 1. No, it is not correct. Somewhere else we did a mistake. So velocity is equal to distance by time. Then time is equal to distance by velocity. Then it is represented with EF only. H is equal to E by T. Frequency is represented by E by T. T power minus 2. Then moment of inertia is equal to time is t power 1. So we made a small mistake. Check this mistake here. Here it is. So h is equal to E by f. Actually it is not E into f. Then you are going to get this is going to be t power minus 1. So you can represent this is as h is equal to E into t, not E power into t. So let me substitute that. It is going to be t power 1. So finally m power 0 L power 0 t power minus 1. T power minus 1 is nothing but 1 by t. 1 by t is nothing but frequency. So the dimensional formula for frequency is the same as h by I. H by I. That is, which option is going to be correct? Option B is correct. Okay, let's solve 23rd question. Okay, the question they are asking is dimensional formula of universal gravitational constant. When two masses m1 and m2 are separated by some distance, let's say r, then gravitational force of attraction between these two masses is g m1 m2 by r square. They are asking gravity. Here g is gravitational constant. They are asking dimensional formula for this gravitational constant. Okay, so even 2022 also, I think they asked this question, 22 or 21, I'm not so sure. Dimensional formula for gravitational constant, gravitational field, potential and potential energy. So try to understand how to write down dimensional formulas here. So here I can write down g is equal to f into r square divided by m1 into m2, where m1 and m2 are masses. Dimensional formula for force is m power 1 l power 1 t power minus 2. R square is distance square, it is going to be l power 2 divided by dimensional formula for masses m power 1 into m power 1. So finally we are going to get m power minus 1 l power 3 t power minus 2. This is the dimensional formula for gravitational constant. Let me solve 24th question. So the question they are asking, the dimensions of Planck's constant equals to, okay, Planck's constant, or you can write down energy dimensional formula is hc by lambda. It is also can be represented as h into f. Now Planck's constant is equal to energy by f frequency or energy into t. So this is time and this is energy. Energy dimensional formula m power 1 l power 2 t power minus 2. Time dimensional formula t power 1. So finally we can represent it as m power 1 l power 2 t power minus 1. Let me check out with the options that they have given. Energy, is energy dimensional formula and Planck's constant dimensional formula are same? No, it is not. Momentum. So what's the formula for momentum? So momentum is equal to mass into velocity. Mass is m power 1, velocity is l power 1 t power minus 1. Is it matching with that? No, it is not. Next, what about angular momentum? Angular momentum formula is mass into velocity into distance, which is equal to m power 1 l power 1 t power minus 1 into l power 1, which is distance. So final dimensional formula is m power 1 l power 2 t power minus 1. Yes, it is matching. So dimensional formula for angular momentum and Planck's constant both are same. So which option is correct here? Option C is correct. So what about dimensional formula for power? Now observe this. Power is nothing but work done divided by time, where work done dimensional formula is m power 1 l power 2 t power minus 2 divided by t power 1. So you are going to get m power 1 l power 2 t power minus 3. It's not minus 1. If t goes to numerator, it will become t power minus 1. That's why we are going to get m power 1 l power 2 t power minus 3. This is not going to match with Planck's constant. So which option is correct? Option C is correct. Very good. Let's get into 25. Already we solved this kind of model. So what is the question they're asking? They're asking us to check out whether energy and torque are of same dimensions or not. Yes, energy and torque both are of same dimension. See, energy dimensional formula is force into displacement, F bar dot d bar. Torque dimensional formula is R bar cross F bar. It is going to be Fd cos theta. It is going to be Rf sin theta. Sin theta and cos theta are dimensionless quantities. F into d is force into displacement. R into F is, that is also length into perpendicular distance from the point of application of force into F will give you the same dimensions. So energy and torque are having same dimensions. The question is they are asking which pair do not have equal dimensions. Okay, let's check force and momentum. So force dimensional formula is m power 1 l power 1 t power minus 2, whereas momentum is mass into velocity, which is equal to m power 1 l power 1 t power minus 1. Are they having same dimensions? No, they are not. Okay, let's. So, which option is correct? I think energy and torque are having same dimensions. It means it is wrong option because they are asking do not have equal dimensions. Force and momentum are not having equal dimensions. Let's check third option, that is option C. Option C is angular momentum and Planck's constant. Just now I have explained angular momentum and Planck's constant in question number 24. They are having same dimensions or different dimensions? They are having same dimensions. Okay, so option C is also wrong. So see, wrong in the sense they are not which is not related with the question. Elastic modulus and pressure already explained. So modulus of elasticity and pressure both are having same dimensional formula. Modulus of elasticity and pressure are having same dimensional formula. Modulus of elasticity is represented as stress by strain, whereas strain is dimensional quantity or a dimensionless quantity. Strain is dimensionless. So whatever the dimensional formula I have for stress, that is equal to dimensional formula for modulus of elasticity. Pressure formula is force by area, which is equal to stress. So this is also having equal dimensions. So only option which is not having equal dimensions is option C, that is angular momentum and Planck's constant are, sorry, not angular momentum. Option B, force and impulse are not having same dimensions. Okay, let me solve question number 26. The dimensions of impulse are equal to the top. Okay, same checking, you just have to cross check it. 26 solution. What about impulse? I told you what is the meaning of impulse. Impulse is equal to change in momentum, which can be represented as F into delta t. Force dimensional formula is m power 1 L power 1 T power minus 2 into dimensional formula for time is T power 1. So finally you are going to get m power 1 L power 1 T power minus 1 is the dimensional formula for impulse. Let's get started. Pressure dimensional formula, force by area, which is equal to m power 1 L power minus 1 T power minus 2. Next, linear momentum. So linear momentum is mass into velocity, that is m power 1 L power 1 T power minus 1. Next, force is m power 1 L power 1 T power minus 2. Next, angular momentum is mvr, which is equal to m power 1 L power 2 T power minus 1. Now look at the option which is matching. That means what's the question they're asking? Dimensions of impulse are equal to. So these are the impulse dimensions which is matching with linear momentum. Which option is correct? Option B is correct. 26th. Very good. Let's try question number 27. So it is somewhat different. So this question number 27 comes in chapter alternating current. Okay, or current electricity chapter also. No, electromagnetic induction. So this kind of chapters, when capacitor, inductance and the resistance terminology comes, then you can understand this. So we are preparing for 11th, it will be difficult for you. There is a formula called a time constant. Time constant formula, if the circuit consists of L and R elements, time constant is equal to L by R. If the circuit is having capacitor and resistance element, it is going to be R into C. This is the direct formula. There is some derivation behind it. Now, what's the question they're asking? Which of the following dimensions will be the same? Okay. So L by R, and they're asking which of the following dimensions will be same as that of time. Okay, L by R and time dimensions are same. That's the meaning. Time constant formula. Okay. Next, RC. Now, if you understand, RC dimensions of RC are same as time, right? Yes. Which option is correct? Option C. Next, this is a formula you have to remember. So when it comes to 12th, or whoever completed 12th, whoever going through the 12th, and then those are the people who can understand. Now let's see question number 29. Which of the following dimensions has the dimension of pressure? Okay, so many times we solve this. Try to understand how many times it is repeated. Pressure is equal to force by area, right? So dimensional formula is m power 1 L power minus 1 T power minus 2. Okay. Next, question number 30. Of the following quantities, which one has dimensions different from the remaining three? Super. Look at question number 30. Let's check each and every option. First one, option A, energy per unit volume. This is also called as energy density. Energy dimensional formula is m power 1 L power 2 T power minus 2 divided by volume dimensional formula. It is L power 3, which is equal to m power 1 L power minus 1 T power minus 2. Nice. Next, force per unit area. Force per unit area. Force per unit area is nothing but pressure. So dimensional formula is m power 1 L power minus 1 T power minus 2. Super. Next, what about third option? Product of voltage and charge per unit volume. Okay, voltage into charge per volume. Voltage can be replaced as work done by charge into charge by volume. With charge will get cancelled. It is going to be work done by volume. This is also can be replaced as energy by volume. So dimensional formula for voltage into charge by volume is the same as first option, which is equal to m power 1 L power minus 1 T power minus 2. Super. Next, option D, angular momentum. Angular momentum is represented as L is equal to m VR, which is equal to m power 1 L power 2 T power minus 1. Now check out what's the question they're asking. Of the following quantities, which one has dimensions different from the remaining three? First option, energy per unit volume dimensional formula. Okay, it is m power 1 L power minus 1 T power minus 2. Force per unit area and voltage into charge by volume, both are same. So only option which is different is angular momentum. So option D is correct. Guys, so there is a small correction in question number 20. Just check it out. So there is L power 1 divided by L power 1 here. So L power 1 will get cancelled. You are going to get m power 1 L power 0 A power minus 1 T power minus 2 as dimensional formula for magnetic field. Just check it out. Let's solve question number 31. In question number 31, they are asking dimensional formula for magnetic flux. The formula for magnetic flux in terms of magnetic field and the area is, actual formula is phi is equal to B bar dot A bar, which is equal to BA cos theta. This is the formula for magnetic flux. We know that cos theta is dimensionless. I've already explained dimensional formula for B. So what's the dimensional formula for B? Here it is, question number 20. Look at this. It is going to be m power 1, L power 0, T power A power minus 1, T power minus 2. Let me represent that. Magnetic field dimensional formula is m power 1, L power 0, A power minus 1, T power minus, question number minus 2. Okay. Let me substitute power minus 2 into area dimensional formula. It is L power 2. So final dimensional formula for flux is equal to m power 1, L power 2, T power minus 2, A power minus 1. This is the formula for flux, magnetic flux. Next, question number 32. The dimensional formula of permeability of free space they are asking. Now we have to check out the formula which relates this. There is a formula for magnetic field due to a current carrying wire, so which is equal to, so let me consider one of the formula. You can use any one of the formula. Magnetic field due to a infinite length wire. Let's say this is plus infinity and this is minus infinity. At a distance A, at this point, if the current flowing through the conductor is I, the formula for magnetic field at this point, which is at a distance A, perpendicular distance, the magnetic field is going to be actually into the board. I mean, right side it is going to be into the board. So right side in the sense with respect to current direction. So magnetic field at this point is equal to mu naught I by 2 pi A. This is the formula for magnetic field due to a infinite current carrying conductor at a distance small a. From this we can find out the dimensional formula for permeability, that is mu naught, which is equal to B into 2 pi A divided by B into 2 pi A divided by I. Very good. What's the formula for magnetic field? Magnetic field is m power 1, L power 0, A power minus 1, T power minus 2. 2 into pi is not having any dimensions. So this is dimensionless. Now I am left with A. So A is a distance. It is going to be L power 1 divided by, current is represented as A. So final dimensional formula you are going to get is m power 1, L power 1, T power minus 2. If A goes to numerator, it will become A power minus 2. So this is the dimensional formula for mu naught. Okay, next 33. Let's see what's they're asking. Question number 33. Which option is correct for 32? 32, it is m power 1, L power 1, T power minus 2, A power minus 2. Option A is correct. Okay. Let us see question number 33. So F is equal to minus eta A dV by dz. This is also called as velocity gradient. What is it? Velocity gradient. Let me read it out the question. So question they are asking is, according to Newton, the viscous force acting between liquid layers of area A and velocity gradient delta V by delta Z is given. This is the viscous force. Viscous force is a frictional force which acts on the liquid surfaces. It's not something which is very different. So eta is constant called coefficient of viscosity. We have to find out dimensional formula for those coefficient of viscosity. Forget about this minus. We need to represent only dimensions. Let me represent those dimensions. A is equal to F into dz divided by A into dV. Can I represent like this? So dz represent